on the right side here is the chip scale atomic clock. You can see it's a pretty small device, and it's really designed for low power applications. Think of remote sensing from the ocean bottom, and actually there's a version of this that is launched into space called the Space CSAC. And today we're measuring the CSAC as well as a sister product called the low noise CSAC, and then next to that we have a rubidium oscillator called the miniature atomic clock. And basically it's a trade-off between low power and high performance between the CSAC and the MAC. And then the one in the middle pairs the CSAC with a low noise crystal oscillator. So to measure this device, we're using a 53100A phase noise test set. And so this is designed to measure high performance oscillators, crystal oscillators, atomic clocks, MEMS oscillators, anything that can produce a frequency between 1 and 200 megahertz. One of the nice things about this particular unit is you can see we just have a single cable coming out for your device under test. And we have no reference input because this particular version has an internal reference oscillator, which is used to compare whatever you're measuring against. And then if you look up here at the software that we're using, this is called Time-Lapse software. And you can see right now we're measuring, this is a frequency stability plot or Allen deviation plot. So it's measuring the frequency stability over various time frames. And you can toggle back and forth between this and, say, a phase noise measurement. So you can look at it both in the time and the frequency domain. And what this plot here is showing you is the purity of the signal that you're measuring. So this particular unit, the LN CSAC, has pretty good phase noise of about minus 85 dBc per hertz at 1 hertz. Another nice thing about this instrument is it's capable of measuring 4 devices simultaneously for frequency drift. So if you want to expand this and use it outside an R&D application into more of a ATE mass production measurement system, you could do that as well. So the last measurement tool that we're using here is something called Clock Studio. And this communicates directly with your CSAC or miniature atomic clock or LN CSAC. And when you connect with a device, it'll give you all sorts of important information like the device serial number, the hardware version, has links to the product webpage, user guide, and data sheet and other important information. But not only that, what's really good for development purposes is you can read all sorts of information directly from the device. So in this case, we're displaying the device temperature. This would be very important to see if you have a specific temperature profile. You could see how your device would perform in such a profile. And this is a tool that's for free on the Microchip website. It's called Clock Studio, and you can download this for any of these products that I mentioned here.